Okay, so now we're going to be doing some warm-up about the definition of the derivative. So we have two situations, a situation where we throw a ball upwards, we have the function that gives us the height as a function of time, so we have to find the derivative of that function, but using the limit definition. So we cannot use the rules for derivatives, so we cannot use the formula sheet. We have to use the limit definition. For number two as well, so we have the formula giving us the concentration as a function of time, and we have to use the limit definition to find the derivative and also calculate some values, some h prime and c prime values, and interpret those in context. So as usual, you should try those yourself. Try to do it by yourself, and then I'm going to give you the complete solution. So try it, and once you're done, well, stop the video, pause the video, try it, and once you're done, come back, and I'm going to tell you, I'm going to give you my solution right here. So I started by writing down my H formula. I have to find H prime of t, and I know that f prime of x is the limit as delta x approaches 0, f of x plus delta x minus f of x over delta x. This is the derivative definition using the limit. So now, as you can see, the variable has a different name. The variable is now t, and the function was once called f is now h. So we have to rewrite the equation. So we have to rewrite this as the lim as delta t. Now it's delta t that approaches 0 of h of t plus delta t. So it's no longer x and delta x minus h of t. All of that over delta t. So it's the same situation but different letters. So it's no longer f, it's h, no longer x, it's t, but same situation. We already have the expression for h of t. We have to find the expression for h of t plus delta t, but we already know that it's going to be the same expression as h of t, but we replace all the t's by t plus delta t. So it's just going to be negative 4.9 multiplied by t plus delta t squared plus 25 multiplied by t plus delta t. And once we have that, we need to expand this one and distribute right here. So it's going to be negative 4.9 multiplied by t multiplied by t is going to be t squared. There's going to be t multiplied by delta t and delta t multiplied by t, because remember that when we have a bracket to the power of 2, we cannot just distribute the power if there is a plus. We have to expand bracket multiplied by bracket. So it's going to be plus 2 multiplied by t multiplied by delta t plus delta t squared. So that's the first bracket, plus 25t plus 25 delta t. So that's the other bracket. And then once we have this, we can just distribute. No, not distribute here, distribute here. This is a single term, so these are all together 2t delta t. So we distribute to this one, and this one. And now we can rewrite that in the limit expression right here. So for the limit as delta t approaches 0, we rewrite all of that, but then the distributed version, so it's going to be negative 4.9 t squared minus 9.8 t delta t, because it's going to be 9.8 if you multiply 2 by negative 4.9, minus 4.9 delta t squared plus 25t plus 25 delta t. So that's for the first expression right here, the h of t plus delta t. But do not worry, a lot of stuff will cancel very soon. Minus h of t, negative 4.9, it looks pretty big, t squared, plus 4.9, sorry, that's a 9, plus 25t between brackets. So that's the original negative 4.9t squared plus 25t. So that's a 9 right here. Sorry for my writing. That's negative 4.9t squared. And now we can see that a lot of stuff will cancel because I got negative 4.9t squared right here. Negative 4.9, but there's a negative in front, so remember that this will distribute and it will become back positive. So this one will cancel this one right here. So those two will cancel out, and the 25t right here is going to be canceled by the negative 25t right here. And all of that is going to be over delta t. And now we can just rewrite the limit as delta t approaches 0 of negative 9.8 t delta t minus 4.9 delta t squared plus 25 delta t, all of that over delta t. And if you try to evaluate the form right now, you're going to see that this becomes 0 because delta t approaches 0, 0, 0, and 0. So you have a 0 over 0 situation, IF situation. But we already know how to solve that. We have to rewrite the limit as delta t approaches 0, delta t factored out, negative 9.8t minus 4.9 delta t plus 25, all of that over delta t. And now you can cancel out the 0 over 0 situation. That's pretty nice. You cannot cancel this one with this one at this point because there's a minus here and a plus here. It really has to be a factor before you cancel out. It has to. And now if you replace delta t by 0, so this right here will approach 0, you can see that the answer is going to be negative 9.8t plus 25. No more limit because there's no more delta t. And all of that is h prime of t. And as well, you can always check that the original function, if you try to find its derivative using the rules, you can check that you should get negative 9.8t plus 25. So that's it for problem A. Now for B, we have to evaluate h prime of 2. Well, h prime of 2, you just have to replace t by 2. So it's going to be 9.8 multiplied by 2 plus 25. So what I got is 5.4. I got it right here. I got 5.4. And remember that you have to put the units because it's from a context. So it was the height of the ball, so it's in meters. And since it's a rate of change, it changes as a function of time. So it changes, it's meters over seconds because it's a rate of change. So it must change over time. So it's meters per seconds. And conclusion, you have to write an interpretation. So the height of the ball is increasing by a rate of 5.4 meters per second when t equals 2 seconds. So that's an instantaneous rate of change. So that's a way of writing down the interpretation. So that's it for problem A. You can take a picture right here. Now we're going to be going towards the other one. So let me grab another sheet of paper right here. I didn't start this one yet. So I have to check the situation, original situation. C of t is equal to 5. Let me write this down. C of t is equal to 5 over 2t plus 20. So we have to find the c prime of t. Once again, we know that c prime of t is now just going to be the limit as delta t approaches 0 as well, c of t plus delta t minus c of t over delta t. I'm not going to be using the red pen anymore. I don't need this one anymore because now we know how to do this. So c of t is right here. We have to find c of t plus delta t. So c of t plus delta t is going to be on top right here. So I have to replace t by t plus delta t right now. So that's what I have to do to find the expression of c of t plus delta t. So it's going to be 5 over 2 multiplied by t plus delta t, just like I previously did. Replace t by t plus delta t, and then distribute. So it's going to be 5 over 2t plus 2 delta t plus 20. Once you have this expression, replace it right here. So it's going to be equal to the limit as delta t approaches 0 of 5 over 2t plus 2 delta t plus 20 minus 5 over 2t plus 20. All of that over delta t. So this expression right here is the first one. This expression right here is the second one, delta t, delta t. So you have exactly the same expression. And now you can put your denominator between brackets because we will have to put on the same denominator, of course. So you have to multiply this one by 2t plus 2 delta t plus 20. Bottom, if you do it bottom, you have to do it top, 2t plus 2 delta t plus 20. And this one, same thing, 2t plus 20 and 2t plus 20. So you have to do it top and bottom for each of those. So it's going to be equal to the limit as delta t approaches 0 of, well, I will distribute, 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 distribute. It's going to be 10t plus 100. 100. I was expecting something more. Minus 10t, 10t, minus 10 delta t, minus 100, minus 100, all of that over 2t plus 2 delta t plus 20, all of that between brackets, multiplied by 2t plus 20. I will not expand this one right here. I will keep it as it is because they're on the same denominator and there's no point in expanding that. So keep it like this, and all of that is divided by delta t over 1 because now I have a 4 level situation. You can rewrite this as a 2 level 1, but first simplify this with this, simplify this with this, and you'll have a nice situation now. The limit as delta t approaches 0, negative 10 delta t over the 2 bracket situation plus 2 delta t plus 20 multiplied by 2t plus 20 bracket multiplied by 1 over delta t. And if you try to evaluate the form right now, we still have a 0 over 0 if situation. So there's no point in doing that. You need to first simplify delta t right here and right here. Those two created the 0 over 0 situation if. And now that you've simplified the two delta t's, you can see that this one as well is going to be approaching 0. So now you can rewrite that as negative 10 over this bracket multiplied by this bracket, so it's just 2t plus 20 squared, and that is c prime of t. You can always check that using the derivative rules. So you do not have, well, now we have to do it using the limit because that was a question, of course, but you can always check your solution using the derivative rules. Now that we're done with A, we have to do B. I'm going to do it right here. Let's do B right here. B is going to be here. Not conclusion yet. We have to evaluate C prime of 3. So I'm going to plug in 3 right here. So it's going to be 10 over 2 times 3 plus 20 squared. And I did my calculations previously. I don't want to be doing that again. I got negative 0.0148. So it's rounded to 4 digits after the decimal. So it's going to be kilograms per liter because it was a concentration, but since it's a rate of change over time, per minute. Because if you remember correctly, the situation was kilograms per liters after t minutes. So time is in minutes. So you have to be careful with that. So, and the conclusion is going to be the concentration of additive is decreasing at a rate of 0.0148 kilograms per liter per minute after 3 minutes. So that's it for my conclusion. So very important, you have to tell us that it's decreasing, you have to give us the value, and you have to tell us that it's after 3 minutes, but because it's going to change for another unit of time. So that's it for the warm-up. You can take a picture of this one as well. So take a picture and practice as much as possible. So see you next time in the next video. Bye.